This video is going to be concentrating on things that can be done using the lathe tailstock. As described before, the lathe tailstock can slide backwards and forwards along the lathe bed, and it can be locked in position using the locking handle at the back. The spindle of the tailstock can be advanced or retracted by turning the handle. To fit tools into the tailstock, we need to have tools which have a Morse taper shank. It's a special taper which has a matching taper on the inside of the tailstock spindle, so that when the tool is pushed firmly into the spindle, it will lock, because it's known as a locking taper. To remove the tool from the tailstock, you must wind the handle all the way back until the tool pops out. This happens because inside of the spindle there is an ejector pin. The tool cannot be refitted unless the spindle is wound far enough out to clear the ejector pin. This is a standard drill chuck, and it's used for drilling on the lathe. Although the drill chuck and the tailstock centre have the same taper on the shank, the Morse taper, there is a slight difference. The tailstock centre has a flat end, and the drill chuck has a tongue milled into the end. This is called a tang. When you're fitting the drill chuck into the tailstock, it must be in the correct position. If you try and fit the drill into the tailstock with the tang upright, it won't lock in. The tang must be horizontal for the drill chuck to lock in. Once the drill chuck is in, tools can be fitted by using the chuck key. The drill jaws can be opened and closed by spinning the collar. Put the tool into the chuck, tighten the collar by hand, and then use the chuck key to fully tighten the chuck. The tool that I've just fitted in is a centre drill. The centre drill performs the same function as a centre punch mark when you're doing hand bench fitting. It provides a guide for a drill to follow. Whenever you're doing operations with the tailstock should be free to move the full length of the bed. To do this, you need to retract the tool post by moving the cross slide outwards, and move the carriage as far as possible to the left to allow the tailstock full access to the workpiece. One thing that you must be careful of, however, is that the tool post or anything else is not going to obstruct the chuck as it turns. So always rotate the chuck one full turn by hand before starting up with the power. When drilling using the tailstock, in a lot of cases, you need to drill to a particular depth. The depth which is drilled can be measured by using the graduation on the hand wheel. The hand wheel has a graduation which from 0, 1 full turn, back to 0, advances the tool 2.5 millimeters. This dial can be zeroed at any point. I'm now going to drill a hole using the center drill to a depth of 6 millimeters. The RPM for the center drill should be set at approximately 1000 RPM for drilling steel. When the point of the tool touches the workpiece, I'll move to the tailstock dial and spin until it's set to 0. 1 full turn will advance the drill 2.5 millimeters. The second full turn will have advanced the drill 5 millimeters. And 1 more millimeter means the drill will have gone to a depth of 6 millimeters. These are twist drills, which are commonly used in the engineering workshop. They come in a wide range of sizes. When a drawing specifies a drilling depth, it means full diameter depth. That means that the depth should be measured from the corner of the drill point, not from the point. I'm now going to fit this drill into the drill chuck. This drill has a diameter of 8.5 millimeters. First thing I need to do is to select the correct RPM for the drill. The correct RPM for this size of drill, drilling mild steel, is approximately 300 RPM. This is the closest speed that we have available on the machine. To begin with, the drill should be advanced until the point of the drill is fully entered the workpiece. At that point, the machine should then be stopped. If the drill is then pushed to the workpiece until it stops, the dial can be then set to 0. The tailstock should be locked in position and the drill retracted slightly. If I'm going to drill to a depth of 15 millimeters, 15 millimeters divided by 2.5 is 6, which means I need to advance the drill 6 full turns to achieve a drill depth of 15 millimeters. The drill begins to cut. 1, 2, 3, 4, sits. The drill can then be retracted. It's very common to produce a chamfer on the edge of a drill hole. That is so that the edge of the drill hole is not sharp. The tool that's used normally to do that is a countersink tool. The countersink tool has an angle of 90 degrees. Once again, the tool should be locked in position just short of the workpiece. Start up the spindle and advance the tool until the cutting edge of the countersink just begins to touch the edge of the drill hole. At that point, the dial on the tailstock should be set to 0. To produce a chamfer or countersink of a depth of 1 mm, I would need to advance to 1 mm on the dial. That will produce a chamfer of 1 mm depth.